Hello everyone. Today I'm going to be walking you through how we're building the socio-technical operating system of the world. My name is Shruti Appiah. I'm the head of product for smart contracts at Input Output, and I have an extensive background in crypto economics as well, as you may know from my other work. And today I'm going to be talking extensively about smart contracts and how they will be used to build the operating system of the world of the future. So I'd like to give you a little bit of an overview of smart contracts first of all, and some of the properties that they have. So the first property of smart contracts is that they're frictionless and they're also quite accessible. So basically anybody that needs to be operating within a smart contract is able to access it fairly easily. So this allows for financial inclusion. It also allows for us being able to give economic identity to anybody that chooses to interact with smart contract. They don't need a lot of prior work in order to onboard these types of systems. That eliminates all kinds of barriers to entry, making this type of a system or this contract fairly accessible. The second property of these systems or smart contracts is that they are strictly enforceable. So since all of the rules and the logic of the system are embedded within the contract as code, these conditions definitely need to be met in order for the smart contract to execute and for the transaction to pass. So all of the conditions need to be met and they are strictly enforceable in that manner. This also, the special property of this is that it allows for us to eliminate any kinds of corruption that might occur in cases where a more powerful party or a more wealthy party might want to bully the less powerful party into submitting into a contract or satisfying some condition in an illegal manner. Thirdly, smart contracts are quite transparent, and this is one of the keys to having an equitable world because it allows us to be transparently viewing any kinds of exchanges that have happened between two parties, and these exchanges are also stored within an immutable ledger, so that means that the source of truth is always going to be trustworthy. And finally, I'd like to talk about, so on one hand we have smart contracts, and then on the other hand, we have the rest of the world, which is already operating on quite a few legacy systems. How are we going to actually reconcile this? In order to build these types of systems, we need a lot of infrastructure. We need a lot of building blocks in order to build up the system in such a way that it will enable and it will interact fairly with our existing world. The first module that we need in order to enable this is programming languages. So we need a way to express the business logic, we need a way to express the rules under which the system will operate with. And for this, we need programming languages because the way that smart contracts are expressed is oftentimes in programming languages. So similarly to this, we have quite a few different programming languages that we're building here at Input Output. We have Plutus, which is based in and embedded in Haskell. We have Malo, which is also embedded within Plutus and Haskell, as well as several other domain-specific languages that we're developing for it to be interacting with other domains as well, such as supply chain, legal. We also have another domain-specific language called Glow. And we also have ways to interact with legacy systems and with legacy libraries and so on. So that's what Yelly is very good at doing. Secondly, we need a way for these programming languages to be interpreted by the systems that we already have. And for this, we need special infrastructure. So one of the first infrastructure that we need for it to be able to, for us to be able to write off-chain contracts and so on is Plutus application framework. Finally, we also need wallet backends so that our wallets through which people are interacting with are able to talk to decentralized applications that will be more user-facing. And finally, we also need several other kinds of infrastructure as they pertain to other languages as well. Thirdly, we need developer tools. And for this, we basically want ways to facilitate the development in such a way that development happens in a decentralized fashion, and that way we'll be able to not only eliminate redundancy, we also would need to make it easy for people to be developing on these platforms. And for that, we need libraries, so that way we're able to create modules through which many different systems can independently interact with. And then secondly, we need development frameworks so that we are able to develop in a more organized manner, as well as testing frameworks so that we're able to test our contracts as well as have some sort of a standardized way in order to ensure that all of these systems operate in a consistent manner. And then we also need integrations. So this really pertains to information sources and data sources through which several different developers can obtain their data from. And for that, we need integrations, we need sources of information as well. We need secure sources, such as we need trustworthy oracles, and we would need several other kinds of data sources. And we also need ways for which these kinds of systems can interact with other systems, so bridges, as well as other specific integrations just between applications. And finally, we also need assurance. So security is primary to these types of systems. And there are many different ways to achieve security, and there's also many different challenges with security. So one of the ways in which we can ensure security is doing it by design. So security by design is one way in which we can ensure that programming language is secure. And so, for example, Marlowe is secure by design, and that's because it imposes certain properties by the language itself that disallows certain types of security vulnerabilities from even occurring in the smart contracts that it builds. Secondly, we also need to ensure that the smart contracts that we have designed perform as they are designed. So that is where assurance and certification comes in. And for that, we have an extensive program in which we have developed 3 levels of certification. The first level being automated security and automated tools for ensuring that there are no race conditions and edge cases and so on. So basically doing all of the basic code checks. And we also have another way in which we are ensuring security, which is through manual audits. This is fairly extensive through the entire ecosystem. So manual audits are also key. And then we also need to mathematically verify that these systems work, and that's through formal verification. And finally, we have economic validation. Now, this is an area that I'm fairly passionate about, and this is also one of the most challenging areas to ensure that the systems actually work as intended. So this basically needs to check for incentive alignment. It needs to check if the economic behaviors that you have designed into the systems and the mechanisms that you have designed into the system will actually meet the goals of the system. The next thing that we need is, finally, we have actually now built all of these infrastructure, and we have built the core of the system. Now we need to have a way for users to be able to interact with the system in a fairly easy manner and in a fairly understandable as well as an accessible manner. And for that, we need usability tools. The first usability tool that we need is a way for decentralized applications to be able to interact with users, and that is typically through wallets. So we need wallets. We also need ways for these wallets to be fairly light and fairly easier to use, and for that we would need light wallets. Secondly, we also need identity, and that's because every user needs to have a single source of identity, and this will also help prevent Sybil attacks. And similarly with that, we're not just interacting with users, that being humans, we're also interacting with users that might be robots, that might be devices as well. And for that, we need key management, we need session management as well, so that we can automate some of these processes. And finally, we need interfaces. Interfaces are ways for any sort of end user or a device to be able to interact with a decentralized application. And one of the key examples of interfaces that we have built so far is Marlowe Run, which makes it extremely simple and extremely easy for anybody to be able to interpret what a smart contract is saying and what kind of conditions and terms they need to meet. Now that we have users, we need to also question ourselves, how can we actually achieve adoption by more users, and how can we actually leverage some of the network effects that come out of having a lot of users within the system. And for that, we have several different solutions. One of the first ways is by having a dApp store. Now, this provides a platform through which users can actually explore the different ways in which blockchain use cases can actually benefit them. And this kind of a technology might be useful for their specific problems. So the dApp store is a portal for exploring any kinds of dApps, as well as ensuring that these dApps are secure. So there's more on that in actually a talk that I give alongside my colleague Ian Pilon. So definitely do check that out. The second aspect of adoption is also we need to have a way for these kinds of systems to be funded, and for these kinds of systems to actually facilitate that decentralized development. And for that, we have Catalyst, in which several projects are posted, and these kinds of proposals are voted on, and eventually they get funded accordingly. And finally, when we do have a lot of users, we also need to ensure that these kinds of systems operate in a favorable manner, even when the bandwidth of these systems may tend to get congested. So for that, we need scalability and we need performance. And for scalability, we have several solutions, one of them being Hydra, which is a layer 2 scalability solution. And this will enable us to scale up our performance and ensure that all of these users that we are onboarding are actually able to adopt it and use it in a way that was previously possible. And finally, we need a way for these users to also be able to participate in governing the system that they are interacting with. And so governance and the different models through which we can govern are also extremely important in this type of a system. Let's not forget who we're actually building for. We're building for end users, we're building for developers, we're also building for protocol developers, the people that actually are building the underlying system. For end users, what's really important to them is ease of use. They also care about performance and scalability. They also care about accessibility, and we're ensuring that the costs need to be low for participating in these types of systems. Secondly, dApp developers is also another key stakeholder in this type of system, because eventually these are the folks that are actually going to be ensuring that these types of systems will continue growing even after we have left the picture. So for dApp developers, what they care about is they want simple integrations. They want powerful integrations as well as easier ways to interact with other apps. So they need good endpoints to be able to interact with other apps. Similarly, they also need documentation of all the different modules that they can use in order to build these types of systems. So that's also extremely important to them. dApp developers also need ways to interact with other systems. So one thing that we are very cognizant of is the fact that this type of a system doesn't just evolve independently. It needs to have other systems to co-evolve with. And so when it comes to building out this ecosystem, we do foresee that this is going to be a much larger ecosystem than simply just what we're building. And we need a way to actually interoperate with those other types of systems. So we need ways to interact with those systems. So one way to do it is through bridges. And we also need to have ways in which developers can actually build systems in a fairly end-to-end fashion. And so we need to provide them an end-to-end developer experience. And one of the ways in which we have achieved that is via Marla Playground, where users can, or developers can actually go from not just building out a smart contract, but also statically verifying it, as well as doing some sort of simulations in order to understand where these types of systems may fail. And so that kind of a system, or that kind of a development environment, actually facilitates a much more end-to-end developer experience, thus making their life much more easier and allowing for an iterative development experience. And finally, we have protocol developers. These are the folks that are actually going to be writing out the logic of the system. They are writing out the rules in which these systems operate. They're also designing the economic rules by which these systems operate. So protocol developers really would care about governance, because that's the way in which most kinds of decisions are being made in terms of the rules that the underlying system operates with. So governance is extremely important. Secondly, they also care about documentation, because that relates to easier interpretability of all of the different rules that have been interpreted in other systems, as well as they also care about modularity as well as composability, so that they are able to actually formulate building blocks on top of which they can build more complex systems. All right, now that we have seen an overview of the different types of stakeholders and the users that are going to be participating in the system, we do hope that all of these building blocks are going to enable us to build the socio-technical operating system of the world. And surely now we're building the socio-technical operating system of this planet, but let's not forget that soon enough we'll be building it for other planets as well. Thank you.